are. Again,
green 6. They're giving you a graph of F. You're supposed to identify the graph of F prime. So giving you a graph of F, you're supposed to identify the graph of F prime. Okay, for tonight, please be careful. There will be problems tonight that ask the other way. They'll be giving you a graph of F, and they'll be giving you a graph of F prime. This will be F prime, and you're supposed to find F. So make sure you can tell the difference.
Is that what 5 was on the?
Yes, yeah. 5 on the blue, that was the problem. 5 on the blue, I just kind of read it quickly when I assigned it, and I messed up. I noticed that, yeah, it was backwards. So they're giving you F prime, and you're supposed to identify F. So watch for that. All right, first thing I like to do is I look at F, and identify all the places on F where the tangent slope will equal 0. So a little chart here. Okay, the symbol F prime, one meaning of F prime is the tangent slope of F. So this symbol means tangent slope of F. So I noticed that at about looks about like negative 1.7. The tangent slope of F is 0. Because the tangent slope at this point is 0. We have a question to that point. I noticed that the same thing is happening here at, say, about the same thing, about x equal 1.7-ish. It doesn't have to be perfect. The tangent slope of F is 0 again. So at x equal 1.7, tangent slope value is 0. I also noticed that at x equals 0 on F, the tangent slope is also 0. Okay. Really good attention, thank you. Do you have any questions about that? Perfect. Okay, the other meaning of this symbol, though, is these are simply y coordinates on the graph of F prime. So I go look at F prime and note that that wasn't very helpful, because every single one of these graphs have y coordinates at 0 where they're supposed to have those y coordinates. So none of them were eliminated by that test. Questions on that? So I build the chart to help me do the next part. So I write F prime, decreasing concave up, concave down. I'll pay someone to talk with me, so I just need a volunteer. It's easier for me to kind of ask questions. Deborah. Look at F, Deborah. I don't care where you're looking. Just pick some part of F that's either increasing, decreasing, concave up, concave down, your choice.
Like -2 to -1.7.
So Deborah says, let's look right here. Right there, we say that F is increasing. So Deborah, if F is increasing from -2 to this -1.7, that tells us what does F prime do over the same interval. Perfect. So I go over here to a possible F prime, and I look at the y coordinates. Are these y coordinates positive, Deborah?
No.
So this is not the right answer. 3 points for Deborah. Anyone have a question? Someone raise your hand and tell me which one is possibly the right answer based on the clue that she identified. These, sorry, your voices, here, Jeff.
C and D.
So C and D. So Jeff, these y coordinates of F prime, are they positive or negative?
Positive.
These y coordinates are positive. That's what we're supposed to have. Because we're looking here and noting that when f is increasing, the y-coordinates of f prime have to be positive. So we've isolated that these two could be possible answers. Questions? Two for Joe. You just keep doing that. So somebody else, any of the different volunteer? Let's go Oakley.
Okay.
So pick another section of f for us to look at.
We could do from 1.7 to 2.
Sure. So 1.7 to 2. What do you see about f in that region?
Is increasing.
Increasing as well. So we expect the y-coordinates of f prime to be positive. So let's see, from 1.7 to, are these positive or negative?
Positive.
Positive, so that's good. All right. These y-coordinates, Oakley, positive or negative?
Negative.
That's not good. Cool. Points for Oakley. Follow-up questions from anyone. There's lots of different ways to do it. That's as good as any. All right, cool. Next one. Blue 7. In the interest of time, Landon, if you have a specific question, I'll answer it. Otherwise, it really is exactly the same analysis as the last one.
Okay, so like the way that I kind of have been taught to figure out tangent slope.
Keep going.
You take your pen, right, and you kind of just fit it to the graph and then kind of analyze its motion, right? So as I was doing that, it wasn't really lining up with the correct answer, so I kind of just got confused somewhere along here.
So where did you find, so were you looking for tangent slopes of 0 to start with, or?
Yes.
Okay. So did you find a tangent slope of 0 here?
Yes.
Okay, let's just keep talking for a minute. Did you find a tangent?
Yes, right
So you
there
did
as well.
No worries. So there's no scale really.
Yeah.
But because whatever this x is and whatever this x is, I expect the graph of f prime to have a y-coordinate of 0 here and a y-coordinate of 0 here. With me on that?
Yeah.
So looking at the possibilities, this one is a possibility. With me?
Yeah.
If I scroll down, these two are as well. Are you good to there?
Mm-hmm.
Let's keep going, you're doing great. So next step, you tell me, Landon, we just need to pick some characteristic of f to focus on. Your choice.
Okay, so as it's,
You know, one thing, you're doing great, I just gotta correct something. Did I mention this in class? Have I mentioned that? Please add this to your list of words to never, like we need a swearing jar to pass around and put money in and invite things for everybody. Yeah, don't say it. The reason is on the AP test, on the written portion, if you start writing, it has a tangent slope of 0 and it has a y-coordinate of 0, the grader gives you 0 points. Like you have to be specific. You say f has a tangent slope of 0, or you say f is increasing, therefore f is, it has to be specific. So you're doing great. Just it's a habit we all have.
okay.
It's every year you just have to fix it. So
Okay, so on the graph
of what?
of f,
F. Perfect. So no pronoun.
or I guess h, because it's
H in this case. Perfect. So the graph of H. Keep going.
Okay, so the graph of h, as it comes from the left side, as the graph comes from the left side, it's increasing.
Let's pause right there for 1 second. You tell me to stop when H is no longer increasing.
Stop.
Good. Yeah, there's no x coordinates, so it's a little difficult to describe. You're doing great. So this portion of H is increasing. So what does that tell you about H prime down?
Well, actually, but
Dang. What does it tell you?
it's telling us that it's constant.
Just don't say
that,
it.
that the tangent line is increasing. It's positive.
Let me say it back to you. So the way you want to say it, Landon, is when h is increasing, you can say the value of h prime will be positive. You can say the y coordinates of h prime will all be positive values.
Yeah.
Good with that? So we look over here, we say, okay, we only have three possibilities. Are these initial y coordinates of h prime, Landon, are they positive or negative?
They are increasing positive. Or so they're negative, but they're increasing, so they're still.
Yes, now be careful with that. We don't care that these y coordinates are increasing. Totally irrelevant. Because we've identified that when the function h is increasing, the y coordinates of h prime should be positive. So whether the y coordinates of h prime go up or down, irrelevant. So I look at this one, are these y coordinates of h prime positive or negative?
Negative.
Negative. So is that good or bad?
That is bad.
Bad.
Yeah.
Bad. Okay, and not the slang bad, which means good. Agree with me?
Yeah.
Landon, these initial y coordinates here, are they positive or negative?
They're positive, but.
Positive.
Yeah.
But they're going up and down, who cares?
Yeah.
They're positive. Good enough?
Yeah.
So good or bad?
Good.
Good. We use sign language. These y coordinates.
Positive.
Positive. Good or bad?
Good.
We use foreign languages. Is that the right spelling?
Yes.
Thank you. It doesn't mean good, right?
Yeah.
Yeah, just checking. Any questions so far? 3 for Landon for being very, 4 actually for being very patient with me. Thank you. We need to pick some other characteristic to test.
So on the H graph, the next tangent line of where y will equal 0 is concave up.
So you're looking kind of in this region here.
Yes, on the H graph, on the H graph. Yeah.
So right here, H,
Is concave.
nice, is concave up. That's myself. Is. So what do we know about H prime on that same interval?
It must be, the H prime must be increasing.
So we're looking for H prime to increase on that same interval. So we check the two possibilities. So we're looking, up and down business is annoying, but, so we're looking for everything to the right of x equals 0. Increasing, got it. So Oakley, do these y coordinates of H prime, are they all increasing? They go up and then down. So that would be that. Nobody else. Yeah, I don't know if that helps.
Landon.
Well, that helps. You get another one. Soothe the pain. Did it help?
It did.
Excellent. Are you good? Good. Anyone else? Okay. I already paid last time.
Oh, I wasn't
Oh,
paid.
you're here, yeah, 20.
I get paid. Yeah, you're.
Only if you were at the Spirit Bowl, you don't get paid, you're over there. So.
Oh, I was there.
Are you sure? You're student council.
Oh, you're talking about that.
Yeah.
I get paid today though. I did my homework.
Word. Yeah, it's up there.
Sweet, thank you. You don't get it. I need that.
Okay, we're gonna skip 6. It's really the same thing again. So, all right. New idea. In your notes, write this down. In your notes, write this down. Write that down, please, in your notes. You'll need this to be memorized and, of course, understood. We we've been talking a lot about, we have a function, and we have the derivative of the function, the function's derivative. F being the function, F prime being the derivative of the function. Questions so far? Okay. However, it's relative. Relative meaning it's simply a matter of how we look at the situation. We could also do this. We could say we have a function called f prime of x. F prime of x is a function as well. So if this function called f of x has a derivative called f prime of x, if we say we have a function called f prime of x, that means there is a derivative of that function. Oh, so let's just say prime, sorry. So the derivative of f prime is, and we have a little blank spot here, we're going to fill it in. So here we got the function f of x, the function f of x, derivative is f prime of x. Now we have a function called f prime. There's a derivative of f prime as well. Pause there, get caught up in your notes. So now I have a question with the general idea I'm trying to lay out so far. I'm going to get everyone to raise their hand on this one. This is a common sense answer. So without me even telling you the answer, if you just kind of use your common sense, you'll probably come up with the right answer. So if you'd like to earn 2 tickets, raise your hand if you're willing to guess what symbol belongs here. And it really just kind of follows the logic. It's not anything new or creative. It just kind of follows the pattern. We have a function called f. We say the derivative of f is called f prime. Now we're saying we have a function called f prime. So what the heck are we going to call the derivative of that function? Derivative of f prime. All you're willing to try is show your hand. Get 2 points for trying. 0 if you don't raise your hand. So
I don't know.
Aspen, what do you say?
F prime of x.
So Aspen says to put right here f prime prime of x. 3 for Aspen. How many would have said that? Show me your hand.
No way.
2 more. Good work.
I thought about it.
Questions, anybody? Pretty good? Okay. Another note here, look, write this down. So f prime of x is called the first derivative of f of x. Write that down. By the same logic, f double prime of x is called the first derivative of f prime of x. It's all relative. Question. Is that written down? So, another thing you can write though is that f double prime of x is also known as the second derivative of f of x. So any questions about the notation or naming? That's all we're doing so far. It's just kind of pointing out that it's just relative what you're considering to be the derivative. So. Okay, pencil stops, we're good. Next thing, because of all that, we can make a chart that is a little more complete than the one we've been using. We can make the first column refer to f of x. The second column refer to the derivative of f of x. So therefore, we already know that this goes like this. someone's going to help me with the next one. So I'm saying if you have a function, you know the relationship between the function and the function's derivative by this table, this chart. But you can also think of f prime as being a function. You can think of this as being the function. Therefore, there's a relationship between this function and this function's derivative. So easy question, but someone just raise your hand and tell me, what is the symbol that represents the derivative of f prime? F double prime. So to probably, somebody answer this question. You already know that if a function, any function, is increasing, then the derivative of that function will have positive y coordinates. Okay, think of this as being a function now. If this function that I'm circling is increasing, someone tell me, what will the derivative of that function?
Would it be concave up?
Kind of missed the idea, but that's good. 2 tickets for a good try. Oh, positive again.
Oh.
You see the match?
Yeah.
You have a function, that function's increasing, the derivative of that function will have positive y coordinates. Same idea. You have a different function. If that function is increasing, what will you say about the y coordinates of that function? They're also positive. The relationship is identical. Question. Please, Brady.
Would there be any things for in f double prime for the positive and negative?
Up here?
Yeah.
No. There actually is no definitive relationship between the function being increasing and the second derivative of that function. Okay, so this must stay blank. Perfect. Always give yourself 2 if I forget to give you 2. Question. So the chart just fills out again exactly the same. Strong one, sorry. Questions? The chart, see how it's kind of stared like a step? You see the step from like here to here? If you keep going, you can have f triple prime, f quadruple prime, et cetera, et cetera, et cetera. It just keeps repeating because the relationship is relative. It's, the old idea that f is to f prime in exactly the same way that f prime is to f double prime. Please, Brady.
If you keep going, will the graph ever look like the original?
Depends on the function. So with with many types of functions, no. With periodic functions, sine and cosine, yes. There's actually if you have f, like if f is sine, f prime is cosine, f double prime is negative sine, f triple prime is negative cosine, and then f quadruple prime would be back to sine again. Any other questions? Awesome. Okay, this chart is what you're going to need for the homework tonight. And really, the part you need is right here. That extra bottom isn't typically, or if ever used. If you ever forget the chart, it's on the wall. So. No. Yeah, there's no definitive relationship here. Yeah, if you notice, there are no other charts in the whole room. There's a reason for that. There's no other concept that you will use more than that one. Like on the AP test, that single idea depicted here will get used more than any other idea. Okay, there'll be lots of other ideas you have to use with it, but this one gets used very often. So, any questions so far? Awesome. Let's do an example. Oh, a couple of things for your notes. Sorry. I said that we have a function called f, and then a function called f prime, which is the derivative of f. And, here's the second derivative of f, the first derivative of f prime. Pretty comfortable with all that. It's time to start throwing in some real life situations with all this stuff. So the next thing you need to write down is, let's go this way. you're going to start dealing with a function that is called position. It describes the position of a particle or the position of an object, meaning how far right or left or how far up and down is the object. The symbol they use to denote position, some problems use the symbol S of t. Some problems use the symbol x of t. Some use the symbol y of t. Some use the symbol h of t. I have not seen any other symbols used to denote these. But I have seen AP questions that use any one of the four for position. Write that down. That means that we can find the derivative of the position. You wrote it in your notes last time. Does anyone, by raising hand, remember the other name for derivative, like the other meaning of the word derivative? You gotta get these all memorized. Let's go ahead.
Tangent slope.
Tangent slope is definitely one of them. I'm looking for the other one, Sarah. Instantaneous rate of change. So 2 points for each of you on that. So derivative or instantaneous rate of change of position. That's this column. So that means this column is s prime of t, or x prime of t, or y prime of t, or h prime of t. Is that written down? I'm comfortable with this. Catch up in your notes. Okay, someone at some point in history got tired of saying the instantaneous rate of change of position. So they invented a word that means instantaneous rate of change of position. You have to remember the word from physics. Velocity. So instantaneous rate of change of position and velocity are the same thing. Questions? Awesome. If we start taking another derivative, we would have written here, let's see, let's write down the first, actually, yeah, the first derivative. The first derivative of velocity, or the instantaneous rate of change of velocity, or the second derivative, lots of words today, of position, we call that, you can call it S double prime of t, X prime prime of t, H prime prime of t, Y prime prime of t, or you can call it V prime of t, or if you get sick of all that, you can call it acceleration. A of t. Let you catch up in the notes again. And you can build a chart with these things. So you can build a chart that looks like this. X of t, V of t, A of t. And the chart would have the exact same pattern as before. Questions? Okay. Let's put that here else and we'll do a couple of examples to show us how it works. In the homework tonight, what you're essentially doing is using either this table or the other table, which is the same thing, this one here, to answer questions about how F f prime and f double prime relate to each other.
Can you just go back to the bottom, just one finish?
Right there. Cool. Okay, if you're done with the notes, turn to the blue packet. I think it's just number 1 in the blue packet's good. So number 1 in the blue. Okay, good. So number 1 in the blue.
Mr. Smith,
Yes.
is Amanda James in your class?
Yes.
You please send her out front for checkout.
Okay. Here we go. In this particular problem, they tell us that we have a function. They call the function y. So instead of using f of x, they simply call it y. They say that y prime is greater than 0. Okay, one person, please raise your hand and convert, like translate for me. What does it mean to say that y prime is greater than 0? Jackson, positive. It means y prime is positive. So follow-up question, Jackson. Does that mean that the y coordinates of y prime are positive, or the x coordinates of y prime are positive? Y coordinates. So we're back to the chart again. 3 for Jackson. We've got some function y. We know that every single y coordinate on y prime has a positive value. So which part of this chart am I interested in? This is a really easy question. Just somebody answer it. Based on the clues so far, which part of the chart am I interested in? So 2 for Braden, Oakley, Hannah, Lexi, Soren, Chad. Who else? Lexi, go ahead. So I pay attention to the fact that because the y prime values are always positive, the y coordinates of the y function will be increasing. So Lexi, are these y values of the function y, are they increasing or decreasing? Increasing. So this one could work. Possibly A. How about B, Lexi? Also increasing. C. So that one's out. D. Increasing and decreasing, so that one's gone. How about E, Lexi? Increasing. 3 tick. We have a question so far. Oh, please, Sarah. See that louder, Sarah.
Can you say what we're legally increasing again?
Yeah, perfect. So are you comfortable, Sarah, that which of the following could be a part of the graph of y? So these are all f of x down here. These are all the original y function. Good. They told us that y prime, which means the exact same thing really as f prime, they told us that y prime always has positive y coordinates. You good with that? So I look over here and know, hey, when y prime has positive y coordinates, that indicates to me that the function y itself will have y coordinates that go up. Does that answer your question?
Yeah.
Perfect. Anybody else? The next clue. Somebody tell me what the next clue means and how to apply it over here in the table. Looking for a hand. Let's go, Deborah.
From the y prime, how do you say that?
Y double prime.
Yeah, double prime is greater than 0, so it is positive. So
Oh, you just got it back to be correct. So less than 0.
Oh, it's less than 0, sorry.
No worries.
So then we know that y in prime is going to be increasing plus.
Perfect. So just restating Deborah's words, they tell you that every y coordinate of y double prime will have a negative value. So you get that on the chart. That tells me I'm looking for a y function that is always concave down. So Deborah, we'll start backwards. Is this function concave up, down, or both? A little of both, perfect. This one here, concave up, down, or both? So that looks good. This one is concave up. Okay. Questions? Please, Brady. So it's B. So the correct answer is B. My drawing is getting a little ragged, but yeah, correct answer. This arrow is a little misleading there, so. There we go. Please, open.
So remind me how she got from y double prime is less than 0, why that made it negative.
Awesome.
Concave down.
So when you see the symbol y double prime being negative, y double prime is less than 0, or if y double prime is negative, they're referring to the y coordinates of y double prime, having negative values. Are you okay with that? So that's what the table is referring to as well. Y double prime has negative y coordinates only when the y from which y double prime came had a concave down. Did that help?
Yes.
Good. What else? Last thing before the bell. Go back to the green. Look at problem 15. Back to the green, look at problem 15, right? Back on the green, look at problem 15. Now, before I finish this example, one caution to everyone in the room. So everyone look at me. Everyone look at me. Okay, the test is on October 4th. It's 85% of your grade. Okay. If you find yourself working on the homework assignment I'm going to text out here in a few minutes, and you're really starting to notice that you're having you're trying to get through every problem, but you're not being very successful, you've got to find a way to come either after school today, and I can stay for a long time today if I need to, before school tomorrow, 6:30, I'll be here at 6:30 in the morning, or after school tomorrow. You cannot wait until class on Thursday. Otherwise, the test is going to become very difficult. You've got to stay up. Question. Okay. 15. They give us a function, f of x in the picture. And they ask us to indicate the signs. Okay, the word sign here means we're supposed to have either a plus, a minus, or a 0. It says the signs of the function. Function is f. The first derivative of the function is f prime. The second derivative of the function is f double prime. They want to know the signs of those three: f, f prime, and f double prime. Questions so far? So one person can help me. We're supposed to look at x equals 0. That didn't print quite right. X equals 0. So I need a volunteer. So Chad. So Chad, I'm just going to run my pen along F. This is F.
Yeah.
You say stop when I get to x equals 0.
Stop.
You found y equals 0. No worries.
Oh.
Do you see the difference?
Yeah, my bad.
Try
Here
again.
you go again. Go again. I'm ready to
You're
start.
good.
Stop.
There you go.
Let's go.
I felt like the Brian Regan joke about the driver's license test. It's like, stop now. No, never mind. No one's heard that. Okay, somebody heard it. All right. So Chad, we're looking right here.
Yeah.
Chad, at that point on F, is the sign of F, meaning the y coordinate, positive, negative, or 0?
Positive.
Positive. I have a question so far. Okay, don't leave on the bell. Don't leave. Just stay. It's going to take 30 seconds. There's 2 ways to find the next answer. Here's the easy way. There's both ways are easy. The tangent slope right here. Will this tangent slope value be positive, negative, or 0? Negative. That's the value of f prime. Question.
Nathan Gray, please come to the attendance office. Nathan Gray, please come to the attendance office for a checkup, please.
We know that there's some tangent slope, and if we were able to calculate that slope, it would come out to be some negative number. And since f primes, y values always represent the tangent slopes, that means the y
Would the
prime
following
is negative.
students please come to the
Last
main
one, use the
office?
chart. F,
Liz
f prime, f double
Galvin,
prime.
Jackson
Okay,
Glover,
f x equals 0.
Landon or London Rowley, Sean Hackett, Lincoln
Concave up.
Grover,
So what will be the
and
sign
Sophia Sorensen.
of the f double
Again, if I
prime y
could please
coordinate?
have
Positive.
Liz Galvin,
Thank
Jackson
you.
Glover, London Rowley, Sean Hackett,
So when you look at
Lincoln
f,
Grover, and
x
Sophia
equals 0.
Sorensen. Please come to the main
there's
office.
f. We're trying to figure out f double prime. So focus right here. At this point, it's f concave up. There you go. Concave up. That means that f double prime y coordinate at x equals 0 has to be